Alright, today we're going to be looking at graphing conic sections and identifying fundamental characteristics of them. Now, in this particular one, we're going to be looking at hyperbolas. We're going to write the equation of a hyperbola given appropriate information. So, while our standard says conics, hyperbolas are included in that. And so, we're going to spend today, or this lesson, on hyperbolas. Now, given the equation of hyperbola, how can we graph it? It's going to be our essential question. So, first of all, let's define what a hyperbola is. An hyperbola is the collection of all points in a plane, the difference of whose distance from two fixed points is a constant. Okay, so we have our two focuses here. Okay, and our graph is going to be equal distance from them. So this is the look we'll end up with. Now we'll go through what everything's called and the same, but for right now this is the same definition of an ellipse, except we have the difference is always constant instead of the sum. The hyperbola has two symmetric parts called branches. So in the pink graph here is called branches. Each branch has a vertex and a focus. The axis that contains the vertex is called the transverse axis. So we have the transverse axis here. And again, we'll go through a little bit more in detail and label everything in just a second. Alright, parts of a hyperbola. I would copy this down and kind of label everything. We'll go step by step through this. Again, these are the branches, and this is the part that we'll end up graphing later on. But for right now, let's go through everything that's part of a hyperbola. First of all, the center. This would be the center. Now we're at the origin. And so starting out, all of our equations of hyperbola will be at the origin as far as our center. Now the graph won't actually touch the center, but that would be considered the center of the hyperbola. And then we have the transverse axis, which basically splits the two branches in half, and that would be the axis of symmetry. And then we have the conjugate axis here. Now, since we're at the origin, they're on the x-axis and the y-axis. And then we have our focus here and our focus here. So we actually have two of them in this case. And then we have our vertices. We have our vertices will be here and here. Noticing that the focuses and the vertices are on the same axis. Okay, that'll be important later on when we're coming up with equations. And then we have two asymptotes. Okay, remember asymptotes, graph will never cross our asymptotes, and it's undefined there as well. Alright, and so we'll be able to come up with the equations of this and a little bit later on. Alright, so the equation of hyperbola can be derived by using the definition of the distance formula. Alright, but for simplicity, I'm just going to give you the formula. We have x squared over a squared minus y squared over b squared is equal to 1, and b squared is equal to c squared minus a squared. Okay, and so it may be helpful to have this rearranged when we're solving for c squared. So b squared plus a squared would be equal to c squared. Okay, so for solving for c, which we'll do later. Okay, so this is the equation of hyperbola. Now, with that being said, what's the difference between this and one with ellipse? You'll notice that this has a subtraction sign. So it looks similar to the ellipse, but the sign in between has changed. Now, to graph an hyperbola, we're going to go step by step with this in a second. But what we'll end up doing is drawing a rectangular box. And so I'm just going to kind of go through this right now. Alright, so we'll start out, we would plot A, and then do the same thing with B. And then we'll end up drawing this rectangular box. And then you'll notice our two asymptotes split our diagonal through the rectangular box that we just drew. And then we would graph our two branches in between the two asymptotes. Now again, we're going to go step by step to this in just a second. Alright, so let's look at an example how we would graph this. We're going to come up with our properties and then graph it. The first thing you need to notice here is that our A value always comes first. Unlike an ellipse, it's not which one's bigger, it's which one comes first. So A squared is equal to 9, therefore A is equal to plus or minus 3. Now what we'll do here is take the 3 and put it in as an ordered pair. Since it's underneath the x squared, that means it's in the x location. So what we'll end up with here is 0, 3, and 0, excuse me, wrote that backwards. So it's going to be 3, 0, and negative 3, 0, because again, it's underneath the x, so our A is going to be in our x location. So we'll go over here and plot our point at 3 and 3. So at negative 3, negative 3, 0, and 3, 0. Now we'll do the same thing for our B value. Now our B value, this would also be our vertices, I'm sorry, up here. Vertices here is 3, 0, and negative 3, 0. Now the B, we just need to draw a rectangular box in. So B squared is equal to 4. Okay, take the square root, and B is equal to plus or minus 2. And so our points for our B values are going to be 0, 2, and 0, negative 2. So we'll plot those there and there. And now what we'll do is we'll draw a rectangular box in here. And that's going to help us to graph this. Alright, so we have our rectangular box there. Alright, now what I would do next is I'm going to draw our asymptotes through this. I'm going to draw it in as a dashed line just so that we understand that alright, so let's draw our little dash line. Well, that's not too good. Alright, so we're going to draw in our asymptotes. And it's going to be diagonal through our box. So that's one asymptote. And then that's our next asymptote. Okay, now we'll draw in our branches. Alright, our branches will have a look something like this, and like this, and then like this, and this. Okay, so we've drawn in our asymptotes and then our branches here. Now, we're also going to come up with our focuses. We'll have one here, roughly, and one here. Now, what we would do with this is we've got an A and B, and our focus is going to be both focuses are going to be related to C values. So, what we'll do here is find C. Now, earlier I told you C was equal to C squared is equal to A squared plus B squared with hyperbolas. So what we'll do is we'll take the 9 and add the 4 to it, so that we end up with C squared is equal to 13. Take the square root, so C is equal to plus or minus square root of 13. Now, this is roughly 3.6. You can take a calculator to it, but so we're going to label it here and here, and to come up with our actual ordered pair, what we'll do is just know that it's on the same axis as the vertices. So what we'll have is square root of 13, 0, and negative square root of 13 and 0. Okay, the only other thing we have to do is come up with the equation of these lines, which we'll do in the next video.